Supplemental math videos from Circle Christian School. The recursive sequence. What came before? The Fibonacci sequence is a series of numbers that are really dependent on the number before it. Another sequence is Pascal's triangle. The row before determines the coefficient of the next row. This is being recursive. When given a recursive rule, you are generally given an initial term to begin with. In this case, it's going to be a sub 0, and that a sub 0 equals 1. That means that's what you were initially begin with, and so when you start using the rule, you're always going to start with the next term. So if it's a sub 0, you're going to start with a sub 1. If it's a sub 1, then you're going to start with a sub 2. And then the rule. And we're going to write the first 5 terms. Notice what's happening here. I move to the next one, a sub 1. Put the 1 in for where the end's at. And I find I get 2a sub 0, because 1 minus 1 equals 0. Well, we know a sub 0 equals 1. Replace it back in, and you get your next term. So 2 equals a sub 1. Now we're going to go find out what to put into the next one. So since n equals 2, we're going to end up with 2a sub 1. And that says, hey, take 2 and multiply it to the last one, which was 2, gives us 4, and so on. So maybe the colors will kind of help you here to see that basically what you're looking for is what's next. But you had to use what came before. This little sequence here reminds me of the Inchworm song. Personally, I think Anne Murray sang it best. If you want to hear her version, look it up on YouTube. A good example is number 1 from 8.2, so that's what I'm going to kind of start with here. And again, a sub 1, which equals 7, tells you where you're going to begin, want the next 5 terms, and you're given the rule, a sub n minus 1 plus 9. And so since we have a sub 1, we start with a sub 2. And we plug in the 2 for the n. Gives us a sub 1. A sub 1 was 7. We add that to the 9, and we get 16. That 16 is a sub 2. And once we find that, we can put it into the next one and get the next term, and then the next term, and the next term, and the next term, and the next term. I think you get the point. A little bit of a different one is when you have to find a summation, and you're given a recursive sequence here. So what's a little bit different about this is, yes, you are given that a sub 1 equals 2, but you'll notice up on top it says, hey, I want you to go to the 4th term. And that could be a little misleading because you're thinking, hey, 4 terms. Well, the little 4 or the little upper index is telling you which a sub, and then the same thing happens. You just replace everything. And we have to make a sum. That means we have to add them all together, and you'll see it equals 20. So take a look at this. I think you'll see the pattern just kind of moving back and forth here. Whatever you get goes in for the next guy.